This part we will see how to extract the internal forces that will be used in order to design the base connection and what are the parameters that we need to consider in our design. So from the previous tasks, you already have the design of the different members. So let's say you have the design of the beam column and the beams, and you already specify these sections from the previous task. We will need to extract is the reaction H and reaction N. And these two reactions, we will use them to design considering the Ideostatica problem. Go back to our model. Make sure that the units is kilonewton meter because you will extract the values considering these units. Analysis, display, and then show forces, stresses, and choose joints. Envelope case, which is the maximum of all the cases that you have defined, and then choose apply or OK. See the reactions in SAP, so you have reactions in this side and the other side. Take the maximum from both sides. As we agreed before, the frame is symmetric, but we consider the wind loading from one direction only, so we expect that the reactions will be different. Not see what is written, right click on the joint and you will see this table. It will show you the values. So here we have the vertical reaction equal to 153 and the horizontal equal to 48 point something. See here I'm just illustrating, so I added the two values of the reaction, so I will use them in design. Let's look at the different parameters that you will see when you are designing a base connection. So it will look like something like this 3D view. Design a base connection in steel, you could have a hinged base or a pin or a fixed base. The difference between these two, as you can see, is the location of the poles. So if you are putting the poles inside the flanges, it's a pin. If you are putting the poles outside the flanges, it's a fixation. Usually the superstructure is steel, but the foundations are reinforced concrete. So we need to link or connect the superstructure to the foundation. And usually we do this using anchor bolts. So we have different types of anchor bolts. You can see that the anchor bolt could be like this one. It could follow a shape of an L, or it could be hooked anchor, or we could add plates at the end of the anchor. And the grade that we have could be 36, 55, or 105. So these are the parameters that we will be choosing using Ideostatica program. So when we say design a base connection, what you need to perform is to get the dimensions of the base plate, also get the number and the diameter and the grade of the anchor poles, and also design the fillet weld that will connect the I-beam to the base plate. This is the summary of the main parameters required to design. You need to calculate the thickness of the plate and also its dimensions, number, diameter, and layout of anchor poles, also size and length of fillet weld. At the fillet weld, you could have only weld lines around the web, or around the web and the flanges from one side only, or around the web and the flanges from all sides. What makes you choose between this and this and this is based on the amount of force that you have, as we will see considering the design in Ideostatica program. Each component that we considered in the design of the base connection, you can do it manually using what we learned in chapter 9 and chapter 10. So what we are performing right now is to take what we learned and use a professional program to apply the same concepts.